Alright, today we're going to be looking at how some more graphing of rational functions, a little bit different from the ones we've done before. Chapter 8, Topic 5. These ones are going to require you to factor. Okay, so first we factor the numerator and denominator of the rational function. If the factors cancel, we have what's called a point of discontinuity. This is removable discontinuity. In other words, it's a hole where the factors cancel. This is a hole where there's no defined value for the output because the input leads to undefined values. So the hole is found by setting the factor that cancels equal to 0 in solving. So essentially whatever the 0 of the factor is, that's where the hole is. We take that solution and substitute it into the simplified equation and solve to find out where exactly the hole is. Then we find the vertical asymptote and the horizontal asymptote, find the x and y intercept, and then we make the table. The rest of this is graphing. This is done after we've simplified, and it will be in a form that we're already familiar with. Okay, so either linear over linear, or what we did yesterday, which I think was constant over linear. Let me double check on that real quick. That was constant over linear. Alright, so let's take a look at how we do this. So we're going to start with number 1. Y is equal to x squared minus 3x plus 2 over x squared minus 1. Y is equal to x squared minus 3x plus 2 over x squared minus 1. Alright, so we'll start by factoring this. The numerator factors into x minus 2 and x minus 1. The denominator is a difference of two squares. It factors into x plus 1 and x minus 1. As we can see, there is a factor that's going to cancel, x minus 1. Okay, so our simplified form is going to be x minus 2 over x plus 1. So this is linear over linear. This is what we did on day 1. So we know how to graph this from day 1. However, we are going to have a point of discontinuity. Okay, so this is discontinuity. Yeah, removable discontinuity. And that's going to be at, let's call it discontinuity at x equals 1. Or let's just say there's a hole at x equals 1. To find out where exactly that hole is, we can put 1 into this here. So let's plug that into the equation to see where exactly the hole is. So we have 1 minus 2 over 1 plus 1, which is negative 1 over 2, which is negative 0.5. So the hole is at 1, negative 0.5. Okay, so there's no defined value there, but that's where the hole is. We'll see that later when we get to the graph. All right, so we want to graph this. So let's look at our simplified version here. So our simplified version, we just said x minus 2 over x plus 1. We know how to graph this from day 1. The vertical asymptote is whatever makes the denominator equal to 0, so that would be negative 1. So we can graph our vertical asymptote here at negative 1, and the graph is not going to cross this. Horizontal asymptote, that is a over c. A is 1, c is 1, so that's going to be at 1. Our y-intercept means plugging in 0 for x. Okay, so if we plug in 0 for x, we get 0 minus 2 over 0 plus 1, negative 2 over 1, which is negative 2. So our y-intercept 0, comma, negative 2. And we can put that on our graph, which is right here. For our x-intercept, we'll plug in 0 for y. So 0 equals x minus 2 over x plus 1. Multiplying both sides by x plus 1. Cancels. So we get 0 is equal to x minus 2, which means x is equal to 2. So our x-intercept 2, comma 0. And we can graph that. That is right here. The hole, we already found the hole. It was at negative 0.5. And for the hole, we're going to put 1, negative 0.5. We're going to put a open circle like that. Okay, that just kind of shows that there's nothing there. There's no value there, that it's a hole. All right, so now in the middle of our table will be the vertical asymptote, which is negative 1, and it's not defined. To the left of that is negative 2, negative 3, and negative 4. To the right of that is 0, 1, and 2. We want to plug in all of these values into the simplified form to graph it. All right, so let's start with negative 4. So negative 4 minus 2 over negative 4 plus 1, which is negative 6 over negative 3, which is 2. All right, let's plug in negative 3. Negative 3 minus 2, negative 3 plus 1, which is negative 5 over negative 2, which is about 2.5. This graph looks very familiar. I think we might have done this exact one on Friday. Negative 2 minus 2 over negative 2 plus 1, negative 4 over negative 1, which is 4. We already have the value for 0. Okay, when you plug in 0, you get negative 2. That's right here. 1, we already have 1. It's actually at negative 0.5. It's a hole. We have that. And at 2, we have that as well. When you plug in 2, you get 0. We've already done those. All right, so let's graph these other ones that we don't have. Negative 4, 2. Negative 3, 2.5. And negative 2, 4. And then let's connect these. Approaches the asymptote. Approaches the asymptote. On the other side, approaches the asymptote, but it's not going to go through that point because there's a hole there. Okay, there's no value here. So the domain, our domain goes from negative infinity to 0, from 0, sorry, not 0, negative infinity to negative 1, from negative 1 to 1, and then from 1 to infinity, okay, because there's no value at 1. 1 is not technically in the domain, okay, because if you plug 1 in to the original equation, it actually is undefined. So even though we have removable discontinuity here at 1, negative 0.5, this is not technically a point, okay? It technically does not have a real output at that value, because if you plug 1 in here, you get 1 minus 1, which is 0, which is undefined, okay? So there's technically nothing there. So our domain runs from negative infinity to negative 1. It runs from negative 1 to positive 1, and then it runs from 1 to infinity. Okay, so that's this piece from here to here, and from here to here. The range runs from negative infinity to the discontinuity here, so from negative infinity up to negative 0.5, and then it runs from negative 0.5 to 1, and then it runs from 1 to infinity. And that is our graph for number 1. Number 2, we have y is equal to x plus 4 over x squared plus 3x minus 4, and this is what we want to graph. First, we will factor it. So we got x plus 4 over x plus 4 and x minus 1. Our x plus 4 cancel. So we got y is equal to 1 over x minus 1. And there's a hole at negative 4, okay, where x is equal to negative 4. This is the form that we did yesterday. This is constant over linear, okay? The actual form is y is equal to a over x minus h plus k. Okay, this is the actual form for this, okay? So if you remember how to do this type, okay, plus, you can assume there's a plus 0 here since k. So let's go back. Simplified, this is y is equal to 1 over x minus, what was it, 1? Whoops. X minus 1. It's a simplified form. Okay, so the vertical asymptote is going to be at h, whatever makes the denominator equal to 0, so h. So that will be x is equal to 1. That's going to be right here. Graph will not cross this line. For the horizontal asymptote, that's going to be equal to k. Okay, well, k is over here at 0, so y is equal to 0. There's our asymptote. The y-intercept, we would be plugging in 0 for x. Okay, so if we plug in 0 for x here, we get y is equal to 1 over 0 minus 1, which is 1 over negative 1, which is negative 1. So we get 0 comma negative 1. 0, negative 1, which is right here. Our x-intercept, we would plug in 0 for y. Okay, so 0 for y, we get 0 is equal to 1 over x minus 1. Multiply both sides by x minus 1. Cancel over here, so we get 0 is equal to 1. Okay, and that means the x-intercept is undefined, and the reason for that is because the x-intercept would be on an asymptote. So there is no x-intercept here, because the x-intercept would be on the asymptote, which is not okay. The hole, we already figured out the hole is going to be at negative 4. We just need to plug that in to figure out what the y-coordinate would have been, okay, in the simplified version. So that means we got y is equal to 1 over negative 4 minus 1, which is 1 over negative 5, which is about negative 0.2. So the ordered pair is negative 4 comma negative 0.2. And that's the hole. And remember that there's nothing technically there. So if I put it on here, -4, -0.2, it should be open like this, okay? There's nothing there. All right, so in the middle of my table will be my vertical asymptote, which is at 1. Doesn't have a value. To the left of that is 0, -1, and -2. To the right of that is 2, 3, and 4. I'm going to plug these values in to figure out what my graph looks like. So I'll plug in -2, so I got 1 over -2 minus 1, 1 over -3, which is -0.3. I'll plug in -1, so 1 over -1 minus 1 is 1 over -2, is -0.5. Plug in 0, 1, y equals 1 over 0 minus 1, 1 over -1, which is -1. Oh yeah, I already have that. It's the y-intercept. If I had realized that, I could have saved myself a little bit of work. All right, we'll plug in 2, 1 over 2 minus 1, which is 1 over 1, so 1. Plug in 3, 1 over 3 minus 1, which is 1 over 2, so 0.5. And plug in 4, 1 over 4 minus 1, which is 1 over 3, 0.3. All right, let me put these on my graph. So I got -2, -0.3, which is like right here. -1, 0.5, -0.5, which is like right here. And 0, -1, which I already have. Let's see, 2, 1, which is right here. 3, 0.5, which is right here. 4, 0.3, which is right here. Okay, so I'm looking like this. Let's go ahead and connect these so I can get a sketch. This goes to the asymptote. Over here goes to the asymptote. Over here goes to the asymptote. Whoops, I don't like that. Okay, make it get close to the asymptote. Over here goes to the asymptote, but remember it hits this point of discontinuity. Okay, so this is kind of what my graph looks like. Point of discontinuity right there. So keep that in mind when you're doing the domain. So the domain starts at -infinity, and then it runs to this point of discontinuity, which is at -4. And it starts again at -4 and runs to right there at 1. And then it starts again at 1 and runs to infinity. For the range, starts here at -infinity and runs up to the discontinuity. So -infinity, and it runs up to -0.2. It runs from -0.2 up to 0. And then it runs from 0 up to infinity. Okay, so 3 different pieces, here to here, here to here, and then from here up to here. All right, so that is our range. Now remember, what we're graphing is this, x plus 4 over x squared plus 3x minus 4. Turns out that this graph looks very similar to 1 over x minus 1. The only difference is that it has a point of discontinuity that this one does not have. Okay, so the reason that we're graphing this one is because it is like this one, just with a point of discontinuity. Okay. All right, here are the practice problems for this topic here. It's just a couple of problems.